Assalamualaikum and hello everyone, we are Group 7 and today we will present our topic entitled Application of Scanning Electron Microscopy SEM in Environmental Pollution Treatment. Environmental pollution, especially wastewater pollution, has become a major concern worldwide. Various treatment methods have been developed to remove contaminants from water before it is discharged into the environment. To evaluate the effectiveness of these treatment materials, researchers use advanced analytical instruments. One of the most important instruments is scanning electron microscopy or SEM. SEM is widely used to study the surface morphology and structural characteristics of materials such as bioabsorbents and biochars. Through SEM analysis, researchers can observe surface change, porosity, and structural properties that influence pollutant removal efficiency. In this presentation, we will discuss the sampling process, sample preparation, SEM analysis technique, data analysis, and conclusion based on 3 selected journal articles.
Next, I will explain the sampling process as in the selected study. In the first study, good hair waste and tannery wastewater were collected from a tannery in Jeshore, Bangladesh. Good hair was selected because it contained keratin, which can be converted into a biosolvent for wastewater treatment. In the second study, olive, pomace, and blue crab shell were collected from food processing industry in Tunisia. These materials were selected because they contain useful organic and mineral components that can be converted into biochar. In the third study, rice husks were obtained from rice mills located in Mbonyi and Nasawara State, Nigeria. Rice husk was selected as a low-cost agriculture waste material suitable for biochar production. Proper sampling is important because it ensures that the material accurately represents the characteristics required for environmental pollutant treatment.
Before SEM analysis, all samples underwent preparation procedures to ensure accurate and reliable results. For the first study, goat hair was washed, dried and subjected to thermal treatment to produce a keratin biosolvent. For the second study, olive, pomace and crab shell waste were cleaned, dried and converted into biochar through a pyrolysis process.
For the third study, rice husks were first pyrolyzed to produce biochar and then chemically activate using potassium hydroxide or KOH. This activation process increased the surface area and porosity of the material. After preparation, the sample were mounted on SEM stock and coated with a conductive material to improve image quality during SEM analysis. Proper sample preparation is essential because it directly affects the accuracy and quality of SEM observation.
Next, I will explain the analysis technique used in these studies, which is scanning electron microscopy or SEM. SEM is an advanced analytical instrument that uses a focused beam of electron to scan the surface of a sample. Unlike conventional microscope that use light, SEM produces highly detailed image with excellent resolution. The main component of SEM include an electron gun, electromagnetic lens, detector and vacuum. During analysis, the sample is placed inside the vacuum chamber. An electron beam is directed onto the sample surface. The interaction between the electron and the sample generates signals which are detected and converted into high-resolution image. SEM is extremely used in environmental studies because it allows researchers to observe porosity, surface roughness, particle distribution, and structural morphology. So, why is SEM important in environmental pollution treatment? The answer is because SEM helps researchers understand how surface characteristics affect pollutant absorption efficiency. Materials with higher porosity and more absorption site generally show better pollutant removal performance. Therefore, SEM is a valuable tool for evaluating and improving material used in wastewater treatment application.
We will discuss the result obtained from SEM analysis. From Journal 1, SEM image show the treated goat hair bioabsorbent had a rawer and more irregular surface. Compared to untreated material, this indicates the formation of additional absorption that they may exchange pollutant removal. For Journal 2, SEM revealed the pyrolysis transformed rice husk into a porous biochar structure. After KOH activation, the material exhibited a denser pore network and increased surface roundness. This characteristic improved the absorption capacity of the biochar.
For Journal 3, SEM image show that olive pomace biochar possess a well-developed porous structure, while crab shell biochar exhibit a rough and heterogeneous surface. After pollutant treatment, noticeable surface deposits were observed, indicating successfully absorption. Based on this finding, SEM successfully demonstrate how different preparation methods influence surface morphology and absorption performance.
In conclusion, SEM is a powerful analytical instrument for studying the morphology and structural characteristics of material used in environment pollution treatment. The three selected studies demonstrate that material modification process improves porosity, surface roundness, and adsorption size, resulting in the better pollution removal performance. SEM provided valuable visual evidence that help researchers evaluate the effectiveness of biosorbent and biochar for wastewater treatment. Therefore, SEM remains an important tool in environment research and will continue to contribute to the development of sustainable pollution treatment technologies. Thank you for your attention.